What is the TON network? The features and improvements.
Hi there. Welcome to Master Telegram Mini App Development, TON Network, Mini Apps, and Hamster Combat. A course designed to spark your creativity and take your development skills to the next level. My name is Ranga, and I'm so excited to be guiding you through this journey. Whether you're a developer curious about the TON Network, an enthusiast looking to build innovative Telegram mini apps, or even someone intrigued by the idea of creating a fun game like Hamster Combat, you're in the right place. This course is packed with tools, knowledge, and hands-on practice to help you turn your ideas into reality. Let me give you a sense of what's ahead. We're going to dive deep into the TON network, a platform that's making waves in the blockchain world. Don't worry if you're new to blockchain. I've designed this course to be approachable, even if you're just starting. You'll not only learn how TON works, but also how to use its unique features to build decentralized applications. It's fascinating stuff, and I promise you'll be hooked once you see its potential. Then we'll shift gears to explore Telegram mini apps. These lightweight, versatile applications are perfect for creating everything from productivity tools to fun, interactive games. Speaking of games, one of the highlights of this course is building Hamster Combat. It's a playful project that will teach you important app development skills while keeping things fun and engaging. What I love about this course is that it's not just about theory. You'll be working on real projects, writing code, and actually building things you can showcase. By the time you finish, you'll have developed multiple applications and gained the confidence to take on even more ambitious projects. Now, before we dive in, let's talk about what you'll need to get started. First, if you've done a bit of programming before, that's great. Maybe you've worked with JavaScript, Python, or a similar language. That foundation will definitely help. But don't worry if blockchain is new to you. I'll explain everything step by step, so you won't feel lost. Of course, you'll need a computer and a good internet connection. Beyond that, all you really need is a passion for learning and a willingness to experiment. That curiosity and creativity are what will make this experience so rewarding. This course is for everyone. You might be an experienced developer looking to explore Telegram's ecosystem and the TON network. Maybe you're an entrepreneur or product manager thinking about how Telegram can help you reach your audience. Or perhaps you're a gamer or hobbyist who just loves the idea of creating something fun and unique. Whatever brought you here, I'm confident you'll find valuable lessons and inspiration in this course. I've also built this course with flexibility in mind. You can move at your own pace, pausing and revisiting lessons as needed. And don't forget, you're not alone on this journey. You'll have access to a community of fellow learners where you can ask questions, share ideas, and get support whenever you need it. I'm so thrilled to have you join me on this adventure. By the end of this course, you'll have not only the technical skills to build amazing apps, but also the confidence to create, innovate, and tackle new challenges. So, what are you waiting for? Let's get started. Click on the next lesson, and let's begin this exciting journey together. I can't wait to see what you create. Thank you for trusting me to be your guide. I'll see you in the next video.
Today, we're diving into how you can Use the CLI to create a new blockchain wallet. The command might look like Tonos Clyde Generator. 2. Deploying contracts. Deploy your first smart contract the TonOS CLI to manage smart contracts on the Ton blockchain. This tool is invaluable for developers looking to work efficiently with blockchain technology. Hi everyone, in this guide, I'm going to be efficient in no time.
In today's video, I'll be showing you how to mine and claim free TON coins for gas fees and other purposes. You'll also get to see a live withdrawal with proof of payment to clear any doubts about this process. If you've ever wondered how to earn TON coins for free, this video will give you a complete guide. So make sure to watch until the end for a step-by-step breakdown. Here's what we'll cover in this video. 1. How to mine free TON coins. We'll go through the steps to mine TON coin without any investment. 2. Claim free TON for gas fees. I'll show you how to claim free TON coin that you can use for gas fees. 3. Withdrawal proof. Watch as I withdraw the TON coins I earned and see the live deposit into my wallet. Now let's move into the steps for mining TON coin. 1. Visit the mining platform. First, I'll open the mining website where I'm currently earning TON coins. You can find the link in the video description below. 2. Check the earned amount. As you can see, I have earned 2.8 TON coins from mining. I'm going to withdraw this amount and show you how it works. 3. Withdrawing coins. After clicking the withdrawal option, I'll provide my wallet address and memo tag to complete the transaction. Don't worry if you don't have a wallet yet. I'll explain how to set one up in another video. 4. Verification. After submitting the withdrawal request, it takes about 5 minutes for the transaction to complete. Let me show you the withdrawal proof. 1. Live transaction proof. You can see that I've received 2.7 TON coins in my wallet after the transaction fee was deducted. 2. Frequently asked questions. Some people ask whether this process is legit or not. As you can see, I've done it multiple times and provided proof. The system works, and you can start mining TON coins for free. In this video, we covered how to mine and claim free TON coins for gas fees and other purposes. I also showed you how to withdraw your mined coins and provided proof that the system works. Hello everyone! In this tutorial, I'll guide you step by step on how to create and deploy smart contracts on the TON blockchain. We'll start by understanding the languages available, and then dive into writing our first contract using TACT. TON supports 3 main programming languages for smart contract development. 1. FIFT, a low-level language specifically created for the TON blockchain. It's a stack-based language, mainly used for managing smart contracts and handling external messages. If you are familiar with assembly-like languages, FIFT could be the right choice. 2nd. FunC, a higher-level language compared to FIFT. It is used for writing the core logic of smart contracts on the TON blockchain. FunC has a syntax similar to C, making it easier for those familiar with conventional programming. 3. TACT, the latest addition to the TON development ecosystem. TACT is designed to be user-friendly and intuitive, balancing low-level control with high-level programming features. Today, we'll use TACT to write and deploy our first smart contract. To get started, open Visual Studio Code. Install TACT Language Support plugin. This plugin will provide syntax highlighting and other features for writing code in TACT. Install FunC Language Support plugin. Even though we're focusing on TACT, it's helpful to have this for understanding generated files. We'll use the Blueprint framework to create a new project. Initialize a new project. Open your terminal in VS Code and type npm create t at latest. Name the project Counter, since we'll be building a simple counter smart contract. Choose an empty TACT project. Follow the prompts to select an empty TACT project, which will set up the necessary files and folders. Let's briefly look at the key folders. Contracts. Contains all smart contract source code written in TACT. Wrappers. Has interface classes for the contracts we develop. Test. Use this folder for creating scripts to test your contracts. Scripts. Store scripts for deploying and interacting with your smart contracts here. Build. This folder will hold compiled files after you run a build command. Open the counter.tact file in the contracts folder. Declare the contract. Start by declaring a smart contract named Counter. This contract is deployable, which means it includes the necessary properties and methods for deploying to the blockchain. Add variables. ID. This will store a unique identification number for the contract. Counter. This variable will keep track of a cumulative value. Set up the constructor. Inside the initialization constructor, provide the smart contract ID and set the counter variable to 0. Define getter functions. Add two functions, one to return the current counter value and another to return the contract's ID. Handle incoming messages. Define a message structure called add, which includes query ID, a unique identifier for the message. Amount, the value to add to the counter. To compile the smart contract, run the build command. Open the terminal, navigate to the project directory, and type npx blueprint build. This will compile the tact code into bytecode, preparing it for deployment. Next, let's deploy the compiled contract. Open the deployment script. Inside the scripts folder, find the deploy counter script. Assign a contract ID. Generate a random number to use as the contract ID, converting it to the required format. Send the deployment transaction. Enter the sender's address, specify the amount of TON coins, and attach the deployment message. Wait for confirmation and log the contract's ID upon successful deployment. Deploy the contract by running the script. Execute the command. In the terminal, type npx blueprint run and select the testnet chain. Sign the transaction. Use TON Keeper. Scan the QR code with your phone and confirm the transaction. Verify deployment. Once the transaction is confirmed, copy the contract address and check its status on TONScan to ensure it is active. Now let's create a script to interact with the deployed smart contract. Create a new script. Name the file increment counter. Define the interaction function. Write an asynchronous function that connects to the smart contract and sends a transaction with an add message to increase the counter. Monitor the counter. Use a loop to check the updated counter value every 2 seconds until the change is confirmed. Execute the script. Choose the script. Run npx blueprint run and select the correct script. Confirm the transaction. Use TON Keeper to confirm the transaction. Check the updated counter value. Watch for the counter value to update on the blockchain. That's it. Today, we covered how to create, deploy, and interact with a smart contract on the TON blockchain using TACT. Keep experimenting with different features and functions to get more comfortable with the process. Thank you for watching. We hope this tutorial helped you understand how to create and deploy smart contracts on the TON blockchain. At Ranga Technologies, we specialize in blockchain development, and we're here to help turn your ideas into reality. Whether you're looking to build a mini app or develop a full-scale decentralized solution, we've got you covered. Feel free to reach out to us for your next project, and let's make your dream app a reality. Hello everyone. In this tutorial, I'll show you how to test your smart contracts without needing to deploy them on the blockchain. This is a great way to save time and resources while ensuring your contract works perfectly. Let's get started. In the previous lesson, we created a simple counter contract, deployed it to the TON testnet, and interacted with it. Let's quickly review the code to refresh our memory. Variables. ID. This uniquely identifies the smart contract instance. Counter. This keeps track of the cumulative count, initialized to 0 and incremented by incoming messages. Initialization. The constructor takes one parameter, the identifier for the contract instance. Getter functions. We defined two functions to retrieve the counter and ID values. Handling incoming messages. A message type called add is used to increment the counter when received. The receive function handles this. In the deployment script, random ID generation. A random integer is generated to serve as a unique identifier for the contract. Transaction. A transaction is sent to deploy the contract with 0.05 TON coins. Confirmation. The deployment is confirmed once it's active on the blockchain. In the increment counter script, initialize contract. We opened the deployed contract for interaction and retrieved the current counter value. Send increment transaction. transaction is sent to the blockchain to increment the counter by 1. Loop. The script checks every 2 seconds for changes in the counter value, and once confirmed, the updated value is logged. Today, we'll test the contract without deploying it to the real blockchain. Create a new project. I'm copying the project from the previous lesson into a new folder called Lesson 3, but you can work within the same project if you prefer. Let's navigate to the Counter Project directory. Open the test script. Inside the test folder, you'll notice an error. It says an argument for ID was not provided. Let's fix that by initializing the counter value to 0. Define variables. We declare variables to store instances of the blockchain, deployer contract, and counter contract. Set up function before each test. Create a sandboxed blockchain environment. Deploy the counter contract with an initial value of 0. Open the contract for interaction. Retrieve a treasury contract used for funding transactions, and deploy the counter contract. Let's run our first test to verify deployment success. Command: run npx blueprint test. Error: the test fails because an argument for ID was missing. Let's update the script and run it again. Success: after saving the changes, the deployment test passes successfully. Now, let's add more tests to our script. Increment test. Create a loop to perform multiple increments. Log each increment for visibility. Simulate multiple users by retrieving a different treasury contract for each increment. Fetch and log the counter value before and after each increment. Generate a random value for the increment and send a transaction to update the counter. Verify the final counter value equals the initial value plus the increment to ensure the contract functions correctly. Let's run the test. Command: run npx blueprint test. Success. Both tests pass successfully, as seen in the logs. Our smart contract increments random values without any issues. That's it for today. Now, you can test your smart contracts without deploying them on the real blockchain. This method is faster, efficient, and saves resources. We hope this tutorial helped you understand how to test smart contracts efficiently. At Runga Technologies, we specialize in blockchain development, and we're here to help turn your ideas into reality. Whether you're looking to build a mini app or develop a full-scale decentralized solution, we've got you covered.
How to build your very first decentralized app.
In today's video, we'll give you an overview of our Mining Telegram mini app. This is the first video in our tutorial series, where we'll guide you step by step on how to build a mining app within Telegram. Let's dive in and explore what the app is all about. 1. Purpose of the Mining Telegram mini app. The Mining Telegram mini app allows users to participate in mining activities directly within a Telegram mini app. The goal is to create a simple and interactive way for users to earn rewards while engaging with the app. It's designed to provide an experience similar to gaming, with added incentives. 2. Key features of the app. Mining for rewards. Users can click a button to start mining and earn rewards in the form of Shipcoin. The app tracks their progress and updates their balance based on completed tasks. Wallet connection. The app allows users to connect their wallet and manage their balance. They can view their mining rewards and even use them for in-app purchases. Upgrading miners. Users can upgrade their miners by paying a certain amount of ton, example, 5 ton for the first upgrade. With each upgrade, the mining efficiency improves, and the cost automatically increases for subsequent upgrades. Referral system. The app also includes a referral system, where users can invite others to join the app and earn rewards for each successful referral. The referral section shows the details of all the users they've referred. 3. Why use this app? It's a great way to engage your audience with an interactive experience while also providing incentives for participation. Whether it's mining for rewards, earning through referrals, or upgrading mining capabilities, the app offers various features to keep users engaged. That's it for this introductory video. We hope you're excited to dive into the rest of our series, where we'll guide you through building each part of the Mining Telegram mini app, step by step. In this video, we're continuing with the second part of our Mining Telegram mini app development tutorial. Today, we'll guide you through the process of creating a Telegram bot using BotFather and generating the bot token. This bot will serve as the foundation for your mining mini app, allowing users to interact and perform mining actions. Step 1. Open Telegram and start a chat with BotFather. First, open Telegram and search for BotFather. BotFather is the official bot that allows you to create and manage other bots on Telegram. Click on BotFather and start a new chat. Step 2. Create a new bot. In the chat, type /newbot and press enter. BotFather will prompt you to enter a name for your new bot. Step 3. Naming your bot. Choose a name for your bot that reflects the purpose of your app. In our case, we'll name it Mining App Bot. After that, you'll need to choose a username for the bot. The username must be unique and should end with the word bot. For example, we'll use MiningBot123. Step 4. Generating the bot token. Once you've successfully created your bot, BotFather will generate a bot token. This token is important because it allows your app to interact with the Telegram API. Make sure to copy and store this token securely. Step 5. Configuring basic settings. You can also configure basic settings for the bot, such as setting a profile picture or writing a short description. To set a profile picture, type /setuserpic in the chat and upload an image. That's it for this video. You've successfully created a Telegram bot using BotFather, and you now have your bot token ready to use. In the next video, we'll show you how to integrate this bot into your Mining Telegram mini app and start building the functionality. In today's video, we'll walk you through configuring your Telegram bot, setting up a GitHub repository for your mining mini app, and installing Tailwind CSS for your project. By the end of this video, you'll have the bot menu configured, your project files uploaded to GitHub, and Tailwind CSS ready to go. First, let's configure the menu button for your Telegram bot. This button will help users navigate your bot easily. 1. Go to the BotFather chat and open the bot settings. 2. Click on Menu button under the bot's configuration. 3. Here, you'll need to add the URL for your mining mini app. For now, this will be a placeholder URL, which we'll replace later once the project is fully deployed. In the future, users will click this button to access the app directly. 4. Save your settings and ensure the menu button is working as intended. Now that our bot configuration is done, let's create a GitHub repository for the project. This will store all of your project's code and make it easy to collaborate or deploy later. 1. Go to GitHub and click on Create New Repository. 2. Name your repository Mining App and choose private or public based on your preference. Click Create Repository. 4. Once the repository is created, click on Upload Files and drag and drop the initial files for the project. These will include your HTML, CSS, and JavaScript files. 5. After the files are uploaded, write a commit message and click Commit Changes to save your files to the repository. Finally, let's set up Tailwind CSS to style your app. 1. Open your project's terminal and run the command to install Tailwind CSS. Bash npm install -d Tailwind CSS. 2. After installation, initialize Tailwind by running bash npx tailwind cs init. 3. Open the tailwind.config.js file and adjust the paths to include all of your project's files. JavaScript content ./src/2 ***.html.js. 4. In your index.css file, import the following Tailwind directives: CSS at Tailwind base, at Tailwind components, at Tailwind utilities. 5. Now you're ready to start using Tailwind classes to style your app. And that's it for today's video. We've configured the menu button in the Telegram bot, set up a GitHub repository for the project, and installed Tailwind CSS to style the app. In the next video, we'll start building the app interface and connecting the bot with the project. In the latest update, Telegram introduced an incredible feature that allows web applications to seamlessly connect with Telegram bots. This breakthrough opens up an exciting world of possibilities. Imagine handling complex tasks, like ordering food, tracking deliveries, or even managing customer support, directly through a bot, without leaving the Telegram app. That's the power of this update. What makes this update revolutionary is its ability to link Telegram's secure messaging platform with your custom web apps. Previously, bots were limited to basic chat interactions, but now, with this new functionality, you can integrate fully responsive web apps into the bot experience, providing a smoother, more interactive interface. Whether you're handling e-commerce, booking systems, or customer services, this change brings the entire user journey inside Telegram. For businesses, this means you can now create web-based services directly within Telegram bots. Imagine your customers being able to place orders, make payments, and interact with your services, all without having to switch to a separate website or app. The convenience this offers to users can greatly increase engagement and customer satisfaction. With custom bots and web app integration, the opportunities are endless. In this series, I'll guide you through developing your own Telegram bot integrated with a web app using React. From setting up your environment to deploying your bot, you'll learn how to leverage this revolutionary update step by step. By the end of this series, you'll be able to build custom Telegram bots for your clients, adding immense value to their businesses. First video of our mini app development series, I'll guide you through building a simple Telegram mini app using Next.js 14. This app will retrieve and display user data directly from Telegram. Let's get started. First, we'll set up a new Next.js project. Follow these steps. 1. Open VS Code and launch the terminal. 2. Create a new Next.js project using the following command: bash npx create next app, at latest 3. During setup, make the following selections. Use TypeScript. Yes. Use ESLint. Yes. Use Tailwind CSS. Yes. Use SRC folder. No. Use AppRouter. Yes. Customize import aliases. No. This will set up the project with all the necessary configurations. Wait a few moments for it to finish. Next, install the Telegram Web App SDK by typing bash npm install twdef-sdk. Clear the console, and now we're ready to begin coding. Let's navigate to the app folder and open the layout.tsx file. 1. Change the title to mini-app and the description to a simple Telegram mini-app using next.js. 2. Add a script tag inside the head tag to load the Telegram web app JavaScript file. This ensures that the Telegram script loads early, making the app function properly within Telegram. Now, open the page.tsx file. 1. Clear all existing code and add useClient at the top of the file. This tells Next.js that the component will run on the client side. 2. Next, create an interface to define the structure of user data we'll retrieve from Telegram. The properties include ID, a number, user ID, first name, a string, user's first name, last name, a string, optional, username, a string, optional, language, code, a string, user's language code, is premium, a boolean, optional indicates if the user has Telegram Premium. 3. Declare a useState variable to store the user data, initializing it as null. Use useEffect to check if Telegram provides any user data, and if it does, save it in the state. Now, we will add some logic to display the data. 1. Create a main element with some padding. 2. Use conditional rendering to check if user data exists. If it does, display a list of user details such as ID, first name, last name, username, language code, and premium status. If the user has Telegram Premium, show yes, otherwise, show no. 3. If no data is found, display a loading message. Before running the app, open the global.css file and clear any existing styles. Now, go to next.config.js and make the necessary configurations to ensure smooth functioning of the app. Finally, run the app using the following command: bash npm run dev. Copy the provided URL and open it in your browser. You won't see any data because the app isn't running inside Telegram yet. To test the app inside Telegram, 1. Upload the project to a GitHub repository. 2. Deploy it to Vercel or any other hosting service. Once deployed, use the app's link to create a Telegram mini app. 3. Open the app in Telegram, and you'll see all the user data retrieved from Telegram, such as the user ID, first name, and premium status, displayed inside your mini app. For users with Telegram Premium, you can provide additional points or rewards within the app. That's it for this first tutorial on how to create a simple Telegram mini app using Next.js. In today's 6th video of the series, I'll show you how to check if a user has joined a specific Telegram channel or group in your mini app using Next.js and Telegram API. This is a key feature to implement if you want to manage exclusive content or track community engagement within your Telegram channel. In this video, we'll cover the following steps. 1. Setting up the Next.js app and creating an API to check user membership. 2. Using Telegram API to confirm if a user is a member of a specific channel. 3. Handling API responses to display results in the front end. By the end of this video, you'll be able to verify if a user has joined your Telegram channel and use this data to provide access to exclusive content. Let's get started with the project setup. 1. Setting up Next.js. Open VS Code and create a new Next.js project with the following command: bash npx create next app at latest. Select the default options and then create an .env file to store your Telegram bot token and other sensitive information securely. 2. Creating the membership API. Inside the app folder, create an API folder and then create a folder called check membership. Inside the check membership folder, create a file named root.ts to define the API endpoint that will check user membership. This endpoint will handle incoming requests from the client and interact with the Telegram API to verify if the user has joined the channel. Next, we'll set up the code to interact with Telegram's API. 1. Bot token and API setup. Retrieve your Telegram bot token from the .env file and authenticate your bot to use the Telegram API. Extract the Telegram ID and channel username from the incoming request. If either is missing, return an error response. 2. Making API requests. Construct the Telegram API URL using the bot token, channel username, and user's Telegram ID. Use the fetch function to send the request to Telegram servers to retrieve membership details. Now let's integrate this functionality into the front end. 1. Fetching Telegram user data. Use the Telegram web app SDK to fetch the user's Telegram data when the mini app is opened in Telegram. This includes getting the user's Telegram ID. 2. Checking membership. Add a button on the front end that lets users enter the channel username and check if they are a member. This will trigger the API to send a request and display the result. 3. Displaying results. If the user is a member, display a success message. If not, show an error message and prompt them to join the channel. Let's test the app to see if the membership check works properly. 1. Build and deploy. Build the app using bash npm run build. Deploy the app to Versal, making sure to provide the bot token as an environment variable during the deployment. 2. Testing in Telegram. Once the app is deployed, test it by entering the Telegram channel username and checking if the membership verification works. If the user has not joined the channel, they will receive an error. If they are a member, it will display a confirmation message. That's it for today's tutorial. We've successfully integrated a feature to check if a user has joined a Telegram channel using the Telegram API in our mini app. This is a crucial feature for community management and exclusive content delivery. In today's 5th video of the series, I'll guide you through connecting your mini app to a MongoDB database using Prisma. We'll also implement a feature to create new users and track user points seamlessly. In this tutorial, we'll be covering the following. 1. Setting up Prisma with MongoDB in your Next.js mini app. 2. Creating new users in the database and retrieving their information. 3. Building a point system that allows users to earn points in the app. By the end of this video, you'll have the skills to connect your app to a MongoDB database and manage user data effortlessly. Let's dive into the code. 1. Project setup. Open VS Code. Create a new Next.js 14 project and select the default options. Install the following packages. Bash npm install Prisma at prisma/client MongoDB tww dev SDK. 2. Initialize Prisma. Run the command to initialize Prisma in the project. Bash npx prisma init. This creates a Prisma schema file, where we will define our database models and configure the environment variables to connect to MongoDB. Let's now configure the database connection and set up user data. 1. Configuring MongoDB. Go to mongodb.com, create a new project, and set up a new database. You'll need the connection string, which includes the username, password, and database name. 2. Define the Prisma schema. In the schema.prisma file, define the user model with fields for Telegram ID, username, points, and other necessary user data. Replace the database URL environment variable with the actual MongoDB connection string in the .env file. Ensure it's secure by adding .env to .gitignore. 1. User Creation API. Create an API route to handle user creation. This route will receive user data. Check if the user already exists in the database, and if not, create a new user entry with default values. 2. Increment. Points API. Create another API route to increase user points. When a user clicks a button, it will send a request to the server, and the points in the database will be incremented. Now, let's integrate this functionality into the front end of the mini app. 1. Fetching user data. Use the Telegram web app SDK to fetch user data when the app is opened in Telegram. This data is sent to our API, where we create or update the user in the database. 2. Incrementing points. Add a button that lets users increase their points in the app. When clicked, it sends a request to the Increment Points API, updates the points in the database, and shows a confirmation message. Let's run the app and test it in Telegram. 1. Build and deploy. Build the app using bash npm run build. Make sure to provide the database URL when deploying to Versal or another hosting platform. 2. Testing in Telegram. Open the app inside Telegram and check the user creation and points increment functionality. You'll see user data stored in MongoDB, and each button click increases the user's points in real time. That's it for today's tutorial. We've successfully connected the Telegram mini app to a MongoDB database using Prisma, implemented user creation, and built a point system. In the next video, we'll continue to expand our mini app's functionality. In today's video, we'll show you how to add a Connect Ton wallet button and display the user's wallet address in your mini app. In this tutorial, we'll be covering 1. Adding the Connect Ton wallet button to your mini app UI. 2. Displaying the user's wallet address in a user-friendly format. 3. How to handle wallet connection and disconnection within the app. By the end of this session, you'll be able to integrate a Ton wallet into your mini app and display the wallet details in real time. Now, let's get started with the coding. Open VS Code, launch the terminal, and create a new Next.js project. 1. Run the command. Bash npx create next app at latest. Select the default settings during the setup. 2. Install the necessary libraries. Bash npm install onlineconnect SDK, onlineconnect UI React. 3. Set up layout and connect the wallet. Open layout TSX and clean up unnecessary imports. Add use client at the top of the file to enable client-side rendering for Ton Connect. Set up the Ton Connect UI provider to wrap your app's components and enable wallet interactions. Let's walk through the code step by step. 1. Creating the metadata for the wallet. Define a JSON file that includes app metadata like the name, icon, and URL. This file is required for Ton Wallet to identify and interact with the app. Upload the JSON file and the app icon to Pinata or your hosting server, and use the IPFS link in your project. 2. Connecting the wallet. In page.tsx, initialize Ton Connect UI, using the use Ton Connect UI hook. This will manage all wallet-related interactions. Use state variables to store the wallet address and the loading state, and define functions to handle the connection and disconnection processes. 1. Display the wallet address. Once the wallet is connected, format the address using the format address function to show a shortened version. Example, first 4 and last 4 characters. 2. Handling disconnection. We've added a disconnect button, allowing the user to safely log out of their wallet. This also updates the app state to reflect the wallet's status. Now that the code is complete, let's run the app. 1. Build the project. Using bash npm run build. No errors, great, the app is ready for deployment. 2. Deploy the app to Versal. Grab the deployed URL and open it in Telegram. You can now connect your Ton wallet, see the wallet address displayed, and even disconnect when needed. That's it for today's tutorial. We've successfully added the Connect Ton Wallet functionality to our mini app. In the next video, we'll explore more features and expand the capabilities of our app. Today we'll dive into building a referral system, adding an invite friend button, and generating invite links that users can share within your mini app. This tutorial is part of the larger project of creating a Telegram mini app, which we've been developing over the past 2 videos. In this video, we'll cover the following key points. 1. Referral system setup. How to create a referral system that tracks user referrals and offers rewards for successful invitations. 2. Invite friend button. Adding an invite friend button to your app's UI to make it easy for users to share the app with others. 3. Generating invite links. How to generate unique invite links that allow users to share the app and track the referrals. Now, let's move into the coding part. We'll start by setting up the basic project and installing the necessary libraries. 1. Setting up the project. Open VS Code and create a new Next.js 14 project with the command npx create next app at latest. Install the necessary libraries. Bash npm install twwdev SDK Telegram app SDK. 2. Defining the referral data. Inside the lib folder, create a file called storage.ts, where we'll define the referral data interface. This interface will structure how we store referral information, including who referred whom. Add the logic for saving referrals and retrieving referral data using functions like saveReferral and getReferrals. Let's walk through the code we just wrote. 1. Storing referrals. We store the referral data in an in-memory storage for simplicity. In a production app, you would use a persistent database. The saveReferral function ensures that whenever a referral ID is received, it's saved correctly and associated with the user who invited them. 2. API setup. Next, we'll define our API routes. Inside the API folder, create a referrals folder and add a route.ts file. Here we define the post and get methods to handle referral data submissions and retrievals. 3. Invite friend feature. We add the invite friend button using a functional component in referralsystem.tsx. This component allows users to send referral invites via Telegram by generating a custom invite link. The button also supports copying the invite link to the clipboard for sharing outside Telegram. We've now completed our referral system, with both the functionality to invite friends and track user referrals working as expected. In the next part, we'll focus on testing the app and refining the user experience. You can check the full app code in the description, or purchase it from my website for further insights into this mini app. In this second video of our mini app development tutorial, we'll dive into implementing JWT authentication and protected routes for a secure Telegram mini app using Next.js 14. This is a crucial step for securing any mini app, especially when dealing with sensitive user data. Let's get started. First, we'll set up a new Next.js 14 project. Follow these steps. 1. Open VS Code and launch the terminal. 2. Create a new Next.js project by running the following command: bash npx create next app at latest. 3. During setup, choose the following options. Use TypeScript. Yes. Use ESLint. Yes. Use Tailwind CSS. Yes. Use src folder. No. Use app router. Yes. Customize import aliases. No. Next, we need to install 2 essential libraries. TWA Dev SDK for interacting with the Telegram web app, SDK, Hosane for handling JSON Web Tokens, JWT. To install them, run bash npm install tbdw dev SDK Hose. Now, let's add JWT authentication to secure our app. 1. In the root directory, create a folder called utils. Inside utils, create a file called session.ts. 2. In session.ts, we'll define a constant key for signing JWT tokens using the secret stored in environment variables. This will be used to encrypt and verify tokens. We'll also set a session duration of 1 hour. 3. Define an asynchronous function called encrypt to create JWT tokens. This function signs the token with the HS256 algorithm and sets an expiration time of 1 hour. Next, create a decrypt function to verify and decode the JWT token, returning the payload if it's valid. To manage user sessions, 1. Define a function called getSession that retrieves and decrypts session cookies. 2. Create another function called updateSession to refresh the expiration time of the session, ensuring it stays valid while the user is active. This function will update the session data stored in the cookies. We'll now validate the Telegram web app data to ensure the integrity of the information. 1. In the utils folder, create a file called telegram.ts. This file will handle the validation process for the data received from Telegram. 2. Define the structure for the user and validation data using TypeScript interfaces. 3. Create a function called validate Telegram web app data to validate the data using the bot token stored in the environment variables. This function will also check that the data is fresh and not older than 5 minutes. Now, we'll create API routes for authentication. 1. Inside the app folder, create a new folder called API, and inside it, another folder called auth. In this folder, create a file called root.ts. 2. In root.ts, define a post request handler that validates the Telegram data and creates a new session for authenticated users. The session data will be stored in a secure HTTP-only cookie. 3. Next, in the API folder, create a session folder and another route.ts file to handle GET requests. This will check if a valid session exists and return the authentication status. We will now add the authentication UI to the app. 1. In the components folder, create a file called telegramauth.tsx. This component will handle the login process for users. 2. Use state to track whether the user is authenticated, and use effect to check the session when the component is mounted. 3. Define a function called authenticateUser to send the Telegram data to the backend for validation. If successful, the user will be redirected to a protected page. 4. Add buttons to trigger the authentication process and conditionally render content based on whether the user is logged in. To protect certain routes in your app. 1. Inside the app folder, create a new folder called Protected. In this folder, create a page.tsx file for your protected content. 2. In the root of your project, create a middleware.ts file. The middleware will intercept requests to protected routes and check if the user has a valid session. If not, they will be redirected to the home page. Now that everything is set up, let's test the app. 1. Run the following command to build the project. Bash npm run build 2. Once the build is successful, upload the project to GitHub and deploy it to Vercel. Don't forget to add your environment variables, such as the bot token and JWT secret, on Vercel. 3. Open the app in Telegram and click on the Authenticate button. If everything is set up correctly, you'll see the validated user data, confirming that you can access the protected page. That's it for today's tutorial. You've successfully implemented JWT authentication and protected routes in your Telegram mini app using Next.js 14. This is an essential feature for any secure app. In this video, we'll guide you through 3 key steps in our mining Telegram mini app development tutorial. We'll cover how to deploy your app to render.com, configure Firebase to store user data, and test the mining app with the Telegram bot to verify everything is working correctly. Let's dive in. First, let's deploy the mining app to render.com. This will allow us to make the app live and accessible online. Step 1. Sign in to render.com. Start by visiting render.com and signing into your account. If you don't have an account yet, you can easily create one for free. Step 2. Create a new web service. Once you're signed in, click on New and select Static Site to create a new web service. Connect your GitHub repository by selecting the repository where your mining app is hosted. Step 3. Deploy the app. After selecting your repository, Render will automatically pull the code and start the build process. You'll see the build logs as the project is being deployed. Once the deployment is successful, Render will provide you with a live URL that you can use to access your app. Now that the app is deployed, let's set up Firebase to store user data, such as their mining activity, balance, and referrals. Step 1. Go to Firebase console. Visit the Firebase console at console.firebase.google.com, https://console.firebase.google.com, and sign in with your Google account. Click on Add Project and name your project. Step 2. Set up a web app. Once your Firebase project is created, go to Project Settings and click on Add App. Select Web App and give it a name. Firebase will generate API keys and other necessary configuration details for you. Copy these as they will be used in the app. Step 3. Integrate Firebase with the mining app. In your app's code, add the Firebase configuration details to your environment files or directly in the code where you are handling user data. This will allow the app to store user data, such as mining stats and referral bonuses, in Firebase. Finally, let's test the Telegram bot to ensure it's working correctly with the deployed mining app. Step 1. Run the bot. Open the Telegram bot that we set up earlier and click Start. This will initialize the bot and connect it with the mining app. Step 2. Test user interactions. Test various user interactions like starting the mining process, checking their balance, and referring new users. Ensure that user data is being updated correctly in Firebase, and the bot responds appropriately to all user actions. Step 3. Verify data in Firebase. Open Firebase console and check the Firestore database to see if the user data, such as mining activity and balance, is being stored correctly. That's it for this video. We've successfully deployed the mining Telegram mini app on render.com, configured Firebase to store user data, and tested the app using the Telegram bot. In the next video, we'll dive into adding more features and enhancing the functionality of the mining app. If you need help with blockchain development, whether it's for Telegram mining apps, Ton, Sui, or Solana projects, reach out to Ranga Technologies. In this exciting new series, we're going to dive into creating a mini-game called Hamster Combat on Telegram. Whether you're a complete beginner or a seasoned developer, this tutorial series will help you build a functional, fun mini-game from scratch using Telegram's powerful API. In this video series, we'll guide you step by step through developing Hamster Combat. we'll cover everything you need to know, from setting up the environment, building game mechanics, designing a smooth interface, to deploying the app on Telegram so players can enjoy it. Telegram mini apps are lightweight, interactive, and reach a vast audience easily. With Telegram's API and bot support, you can create amazing experiences for users. And Hamster Combat will be no different. It's a simple yet engaging turn-based game, where players control hamsters in a battle for victory. In this series, we'll start by setting up your environment, then move into developing the game's logic and mechanics. You'll learn how to design the gameplay, create user-friendly interfaces, and test the game right inside Telegram. By the end, you'll have a complete mini-app that's ready for deployment. To get started, you'll need a basic understanding of JavaScript, Node.js, and a Telegram account. If you're new to these, don't worry, we'll guide you through every step. By following along, you'll learn the entire process of creating a mini-app for Telegram. Hamster Combat is a turn-based battle game where hamsters fight for glory. Players can attack, defend, and use special abilities, creating unpredictable and fun gameplay. We'll also cover adding animations and multiplayer features to make it even more exciting for players. Excited to start building Hamster Combat? In the next video, we'll set up the development environment and lay the foundation for our game. Today, we're diving into an exciting tutorial series where we'll build a fun Telegram mini-app called Hamster Combat. In this first part, we'll focus on setting up the project and preparing everything for development. In this video series, we will break down the entire development process, starting with cloning a GitHub repository, setting up the environment, and creating a working mini-app from scratch. By the end of this series, you'll have your own Hamster Combat app, where users can interact with a cute hamster card and earn points. This is perfect if you want to learn how to integrate apps with Telegram or work on small, engaging projects. Let's start by preparing the project. First, clone the GitHub repository that contains two branches, the initial setup and the final version. You can follow the link to get the repository, and then clone it using your terminal with the following command: git clone, https github.com, your repo link.git. Once cloned, navigate to the project directory using the command cd hamster combat. Next, let's install the necessary dependencies. We'll be working with Vite for this project, which is a fast build tool for modern web development. Here's the command to install dependencies: npm install. After the installation is complete, you can now run the project locally by using npm run dev. That's all for today's setup. In the next part, we'll dive deeper into UI adjustments and prepare the project for mobile device screens, which is crucial for Telegram mini apps. Stay tuned for more in this tutorial series. In this second part of our Hamster Combat mini app series, we'll focus on adjusting the user interface for mobile devices. In this part, we'll be using browser inspection tools to fine-tune the UI of our mini app. Telegram mini apps run primarily on mobile devices, so ensuring our app is responsive is key. To begin, let's position the VS Code editor and the browser side by side. This allows us to instantly view the changes we make in our CSS. You can open the browser inspection tools by right-clicking on the page and selecting Inspect. Once open, adjust the view to mobile screen size to see how the app looks. We'll now use Tailwind CSS classes to make some quick layout adjustments. We can apply Flex and Justify Center classes to ensure that the hamster card is centered on the screen, regardless of device size. Let's modify the CSS file like this. This ensures the background color and layout are optimized for a better mobile experience. In the next part, we will focus on improving the overall design of the app by adding animations and visual effects. Welcome back to part 3 of our Hamster Combat mini app series. In this part, we're going to style the app and make it visually engaging. We will use Tailwind CSS to style various elements of the app. From backgrounds to text colors and flexbox layouts, we'll turn the simple UI into something more polished. Let's start by adding a custom background color to the entire app. Using Tailwind CSS makes this simple. We can apply classes directly in the HTML code. Here's how we can set a gradient background for a more dynamic look. Div class, BG gradient to R from blue 500 to purple 509 in illuminate screen. This adds a gradient effect from blue to purple, giving the app a more engaging look. We'll now work on the layout. By using Flexbox, we can ensure that our elements are evenly spaced and centered. Tailwind's Flex and Justify Around classes will handle most of the layout for us. Div class. Flex Justify Around P4. Div class. Hamster card. Div class. User stats. This positions the hamster card on one side and the user's stats on the other. Welcome to part 4 of the Hamster Combat Mini App series. In this tutorial, we'll make the app more interactive by adding dynamic components and tracking user progress. We'll be implementing a state variable to track the user's level and points. By the end of this tutorial, you'll see real-time feedback as the user interacts with the hamster card. We'll use React's use effect to track the user's level and points. As the user clicks the hamster card, we'll increment their points and levels dynamically. Next, let's display the points and level on the screen. This simple setup tracks the progress and reflects it on the UI. In the next part, we'll implement animations to make the app more visually appealing. Hi again, and congratulations on making it to the end of Master Telegram Mini App Development, Ton Network, Mini Apps, and Hamster Combat. You've done an incredible job working through the lessons, building projects, and expanding your skills. Whether this was your first time exploring the Ton Network or you came in with experience, you should feel proud of how far you've come. Take a moment to reflect on what you've achieved. It's no small feat. From diving into the fundamentals of Ton to creating mini apps and even building your own hamster combat game, you've gained practical, hands-on experience that you can take with you into future projects. Let's quickly recap what we've covered in this course. We started with an introduction to the Ton network, exploring its scalability, security, and unique features that make it a game changer in the blockchain world. You learned how to leverage these features to build decentralized apps that are both efficient and user-friendly. We then transitioned to the exciting world of Telegram mini apps, where you developed lightweight, interactive applications that seamlessly integrate with Telegram. These are powerful tools that can be used for anything from business productivity to personal projects. And now, you have the skills to create your own. Finally, we got creative with Hamster Combat, an interactive game that not only showcased your technical abilities, but also demonstrated how to build engaging and fun user experiences. This project was a great way to combine technical knowledge with a bit of playful creativity, and I hope it's something you enjoyed working on as much as I enjoyed teaching it. Now that you've completed the course, you're ready to take these skills into the real world. Whether you're building apps for clients, launching your own projects, or exploring new opportunities within the Telegram and Ton ecosystem, you've got a strong foundation to work from. If you're thinking about what's next, here are a few ideas. Start by expanding on the projects you built during this course. Could you add new features or refine the user experience? Explore opportunities in blockchain development, where Ton is quickly becoming a leading platform for decentralized solutions. Experiment with creating mini apps for businesses, communities, or even for personal use. Telegram's API and developer tools are incredibly versatile, so don't be afraid to get creative. And don't forget, you're now equipped to tackle even larger, more complex projects. The possibilities are endless, and I can't wait to see what you create. Remember, learning doesn't stop here. You're now part of a larger community of developers and innovators who are exploring the potential of Ton and Telegram. Don't hesitate to stay connected. Reach out to your peers, join online forums, and share your work. If you ever feel stuck, revisit the course materials or post in the discussion board. I'm here to support you, and so is your learning community. Collaboration and feedback are powerful tools for growth, so make the most of them. As we wrap up, I just want to say how grateful I am to have been part of your learning journey. Watching you progress through this course, build your projects, and grow as a developer has been incredibly rewarding. The skills you've learned here have the potential to create real impact, whether it's in the form of innovative apps, creative games, or entirely new solutions to challenges in the digital world. Remember, every great idea starts with someone who's willing to take the first step. And you've already done that. So, as you move forward, keep experimenting, keep learning, and most importantly, keep building. The world needs more creators like you, and I'm excited to see what you'll accomplish. Thank you so much for taking this course with me. If you found it valuable, I'd love to hear your feedback. Don't forget to leave a review. It helps me and others who might want to join in on this journey. Until next time, keep coding, keep dreaming, and keep creating. Goodbye for now, and best of luck in all your future projects.